Hey everyone. Let's go over some basic log equations now. So now we're not learning anything new here necessarily. We're just going to be applying a lot of the skills that we've already learned to solve some of these logarithms. So remember, we have log base a of c is equal to b if and only if a to the b is equal to c, and c must be greater than 0. So that's another thing I probably haven't emphasized as much as I probably should have up to this point, but it's important to emphasize it now. Logs are really only defined for positive inputs, so we haven't really had any chances to see where that might fail. Foreshadowing here, we're gonna see at least one example where things fail here. So logs are only designed for positive inputs. Okay, if you have a negative input, you're not going to get a solution. It's not defined. Okay, so let's keep that in mind moving forward. So here we have 3 plus log base 4 of 5x is equal to 4. Okay, so first what we want to do is anytime we're solving for x, you want to get x by itself on one side. So you slowly want to start working in that direction. So let's go ahead and take 3 away from both sides of the equation. So then we're going to have log base 4 of 5x is equal to 4 minus 3, which is 1. Okay? So now remember our rule here. Log base a of c is equal to b if and only if a to the b is equal to c. So we can rewrite this as 5x is equal to 4 to the 1. And 4 to the 1 is just 4. So that gives us 5x is equal to 4. Then we can divide both sides by 5. And we get x is equal to 4/5. Okay? So let's double check our work here. So to check, okay, we have we can go to this one here. We don't have to necessarily go all the way back to the beginning. We can go to this one here. We should have log base 4 of 5 times 4 over 5. This is equal to log base 4 of 4. And so what number, if we raise 4 to some number, we should be able to get back itself. That will be 1. So that confirms our answer is correct. Okay, let's try another one. Here we have negative 3 plus log base 2 of x plus 2, and that's equal to negative 2. So as before, let's go ahead and add 3 to both sides to isolate log base 2 of x plus 2 by itself. That's going to give us log base 2 of x plus 2 is equal to 1. Okay, and remember, we have, if we go back to our log rule, log a of c is equal to b if and only if a to the b is equal to c. So we have 2 to the 1 is equal to x plus 2. Okay, 2 to the 1 is equal to x plus 2. So we can solve now for that. We have x plus 2 is equal to 2. We can take 2 away from both sides, and we get x is equal to 0. Okay, so we have, log, let's just confirm this is right. We have log base 2 of 0 plus 2 is equal to log base 2 of 2. So that should be 1. We have 2 to the 1 is equal to 2. So there we go. That is going to be a valid answer. So x equals 0 is indeed a valid solution. Now we have log base 2 of x minus 5 is equal to 3 minus log base 2 of x minus 7. Okay, well, let's see what we have here. So the way we're going to do this is we're probably going to need to use the quotient or product rule here. So let's go ahead and let's see what we can do. Let's take log base 2 of x minus 7, and let's go ahead and add this to both sides. Okay, so we're going to have log base 2 of x minus 5 plus log base 2 of x minus 7 is equal to 3. Okay, so what we can do here is now we can use the quotient rule. So if we add two logs together with the same base, we can write it as a single log with their inputs multiplied. So we can write this as log base 2 of x minus, write this better, x minus 5 times x minus 7 is equal to 3. Okay? So we have then, from our log rule, we have 2 to the 3 is equal to x minus 5 times x minus 7. Okay? Or we have 8 is equal to x minus 5 times x minus 7. I need some more room here. Okay, so let's FOIL this out. So this is going to give us that 8 is equal to x squared minus 7x minus 5x plus 35. Or we have 8 is equal to x squared minus 12x plus 35. And then from here, we can go ahead and subtract 8 from both sides, because remember we need to set this equal to 0. So we're going to have, after we do that, we'll have x squared minus 12x plus 27 is equal to 0. Okay, so we can either use the quadratic formula or we can try to factor this. I think factoring it would make sense here. So we can do -9 and -3 for our factoring here. So that'll give us x minus 9 times x minus 3. And that's because we have -9 times -3 gives us positive 27. And -9 plus -3 gives us -12. So this is going to be equal to 0. And therefore, our two solutions, or two potential solutions, are x equals 9 and x equals 3. So let's see if one or both or neither of these solutions will work. So if we check x equals 9, okay, really what we need to do is we need to make sure that these are positive. That's really the thing we're looking for here, is that everything is positive. We check x equals 9. We need to make sure that x minus 5 is positive and x minus 7 is positive. So we have 9 minus 5 is 4. That's good. And then we have 9 minus 7 is 2. And that is positive, so that is good. But let's check 3. So if we have 3, we have x equals 3. We're going to have 3 minus 5 equals -2. So we can stop there. We know that x equals 3 is not part of our solution. So x equals 9 is the only valid solution for this equation. Okay, now let's try this next one. Here we have log base 5 of x minus 7 equals 1 plus log base 5 of x plus 1. Okay, well, similar to last time, let's go ahead and take log base 5 of x plus 1 away. From both sides. Okay, so these will cancel, and we'll have log base 5 of x minus 7 minus log base 5 of x plus 1 is equal to 1. Okay, and now we can use our quotient rule. Remember, if we subtract two logs at the same base, we can divide their inputs under a single logarithm. So we have log base 5 of x minus 7 over x plus 1, and that's equal to 1. So now we can rewrite this using our basic definition of logarithms as 5 to the 1 is equal to x minus 7 over x plus 1. And then that's equal to 5, right? So 5 to the 1 is equal to 5, so we can just rewrite it as that. Okay, so now what we can do is go ahead and multiply both sides by x plus 1. Okay? So multiplying both sides by x plus 1. So we have x minus 7 equals, we're going to distribute here, 5x plus 5. Okay? And so then what we can do is we can go ahead and, to keep everything positive, we'll take x away from both sides. And that's going to give us -7 is equal to x plus 5. And then we have, if we take 5 away, we'll have x is equal to -12. Okay, so let's see. The only problem we have here, though, is that if we plug in x equals -12 right here, we'll have -12 minus 7. That's obviously going to be a negative number. So actually, this is not going to work. And that was our only possible solution. So since we've excluded that one, we have to say there is no solution.